Hello, and welcome to the screencast in which I am going to talk about the smells unit of Living by Chemistry. Again, Scott Balicki, and you can see my email address there. Feel free to email me if you ever have any questions about the curriculum. In this screencast, I'll be giving you an overview of the smells unit, talking about 3 difficult lessons in detail, and providing some additional resources. So the smells unit is shorter than the alchemy unit, you may notice, and it's divided up into 4 sections. The first section, speaking of molecules, is the section in which students learn about the evidence for the structure of molecular covalent substances, i.e. their smell. Then in lessons 9 through 14, they build larger molecules and examine conflicting evidence about which structural features are essential in order to identify a smell. In section 3, molecules in action, students learn about interactions between molecules and ultimately interactions between those molecules and receptors in our noses. And in lessons 20 and 21, the molecules in the body section, students learn about mirror image isomers and also a little bit about amino acids in order to wrap up the unit. So I'm going to give a quick walkthrough of all of the lessons in the smells unit. So lesson 1 begins with the students having an experience of categorizing certain molecules according to their smell, and they come up with a couple of smell categories. They have a sense of having figured out the rules of how you would be able to predict them. But in lesson 2, they have a discrepant event in which they find that their ability to predict smell is somewhat limited, and they need to learn about structural formulas. Structural formulas are based upon the Lewis dot structure model, which students learn about in lesson 3, lesson 4, and lesson 5. Lesson 4 has an online application, which I will share at the end. In lesson 6, students categorize smelly molecules according to repeating structural features entitled functional groups. And in lesson 7, one of the difficult lessons, students take molecules which have certain functional groups and perform chemical reactions in order to transform them to other molecules which have different different functional groups. In lesson 8, they make sense of that lab experiment. Then if we move on to the building molecules section, in lesson 9, students learn about ball and stick models. In lesson 10, students learn about electron domains as either lone pairs or bonded domains and how that can contribute to the overall shape of a molecule. They build some molecules and learn about certain shapes or Vesper geometries in lesson 11. And in lesson 12, another one of the difficult lessons, they examine space-filling models for overall shape of, I would say, medium-sized molecules with like 8 to 20 carbons. In lesson 13, they kind of synthesize everything that they've learned so far and compare functional group to overall shape. And in lesson 14, they study the current understanding of the mechanism of smell, so how these molecules are interacting with us when we go through the process of smelling them. In section 3, lesson 15, our third difficult lesson, involves looking at the macroscopic interactions between a charged wand and certain liquids. Then they read a comic and answer some questions. They really read a comic. It's very clever in lesson 16. And in a clever way, learn about a model for why certain substances were attracted to the charged wand and others were not. In lesson 17, they formalize this understanding and learn about the electronegativity scale and therefore polar bonds. In lesson 18, they look at how what they've learned about polar molecules can result in different types of interactions between polar molecules and polar receptors. In lesson 19, again, this is another synthesis lesson where students combine evidence from several perspectives in order to summarize what they've learned so far about smell. The last section is 2 lessons. One is about mirror image isomers or enantiomers, and the other is about amino acids as molecules composed of a couple of functional groups which build up the proteins which make up the meat of us. So it's a very interesting way in order to end the unit. So this unit has what I've considered to be 3 particularly difficult lessons worthy of more discussion. So the first one is lesson 7, create a smell. This is a lab experiment and will require a lot of thought in your context in order to set it up properly so that students can discover that they can synthesize new smells in a safe manner. So a couple of recommendations. The alcohols and the carboxylic acids should be organized in a certain area that you can supervise in order to prevent cross-contamination. It's essential that they not be cross-contaminated, otherwise the experiment won't work. Now, this experiment also uses an 18 molar sulfuric acid catalyst. This is something that should not be handled by the students. What I do is, after students have made all of their initial observations mixing the alcohol and the carboxylic acids in a test tube and have prepared their hot water bath, I have them set the test tubes down on the bench in a test tube rack, and I myself go around and put the 1 drop of 18 molar sulfuric acid catalyst in each, in order to ensure that there's no spilling of the sulfuric acid on the outside of the container and that the drop goes into the solution in order to catalyze it. Gloves are a very good idea for this lesson. Students really should be wearing gloves in addition to goggles during this lesson. But other than that, as long as the lab space is well ventilated, they can have a common experience of starting out with things that smell alcohol-y and putrid and ending with substances that smell sweet. So it's a very engaging experiment for the students. Difficult lesson number 2 is lesson 12, what shape is that smell? The reason it's difficult would be if you're a new teacher. If you are making these space-filling models, they really need to be made in advance. Otherwise, it will take up, at minimum, a whole class period for students to make them themselves. And that's not really time learning anything. That's just kind of time trying to make these space-filling models work. So if you are new and do not have these sets already made up, it's time to put on some nice light binge watching TV in the background and build those models in advance. Otherwise, it will eat up an awful lot of class time. The third difficult lesson is attractive molecules, where students learn about polar versus nonpolar liquids. You're going to need a chart like a plastic rod in order to carry the charge. If you don't have those, a styrofoam cup would do the same thing. You can use a burette, as they recommend in the lesson, but as you see in this image here, a plastic cup with a hole poked in the bottom is a useful substitute. And you'll notice the woman in the image is also showing the orientation of the water molecule. That's a nice micro-macro connection that she's making there. Perhaps it doesn't have to be made in lesson 15, but I think what she's doing is a good idea. Another thing to consider is the ventilation in your room, because hexane is not a substance which you, the teacher, want to be inhaling for the whole day. So I will be performing the hexane as a demonstration, because I do not think it is safe for me to be inhaling hexane 5 periods a day every year for the next 15 years. So that's a good thing to consider, is the safety of inhaling hexane when performing this lesson. So here are 3 resources. One is the Lewis Dot Structures app, and this is from lesson 4, where you can actually carry it out in a little clever application. Supplemental lessons and animations I have linked to my website. You can get to it there. And of course, the pacing guide, student learning objectives, and calendar from the BPS Science Weebly. You can always contact Pam, Holly, or myself if you have any questions about this. And now, having enough time, we can just take a look at what that application looks like. So we just drag the hydrogen over here, and we link it up, and we've made methane. There are pen and paper cutouts that students can do to use the puzzle, but this is a fun application if you have access to computers. So thank you for listening, and I look forward to hopefully your viewing of future screencasts of the toxins and the weather units.